Hello, viewers of Akshi.com by Vetri from Pondicherry. Today, I am going to continue further the Stoichiometry part 2. I have already discussed in the previous class regarding Stoichiometry, what is Stoichiometry, and under the Stoichiometry, what are the rules, how to follow the rules to write the stoichiometric equation I have discussed. In this class, I will continue further to take lecture on how to balance a chemical equation by ion-electron method. Okay, let me discuss in detail. Kindly follow me. So, what we are seeing here in equation is a redox reaction. It's an unbalanced equation. So, I am going to teach you how to balance this equation by ion-electron method. So, in this reaction, you can see here, potassium permanganate, an oxidizing agent, reacts with ferrous sulfate, a reducing agent, in presence of acid medium sulfuric acid to produce the products potassium sulfate, manganese sulfate, ferric sulfate and water. So this is an unbalanced equation, that is the equation without balance. So I am going to teach you how using ion-electron method we can balance this. Kindly follow me. So we have to follow certain steps. They are nearly approximately, I can say you, there are 5 steps we have to follow to balance ion-electron method. Step 1. Step 1 is the most important. Let me read now, I will explain. Split the complete equation, redox reaction here, into 2 separate half reactions. One for the change undergone by the oxidizing agent, and the other for the change undergone by reducing agent. So this is the step 1. So from the step 1, what information we are getting? One is, we have to identify oxidizing agent, we have to identify reducing agent, then we have to write these 2 simple half reactions, that is ionic reactions, one for oxidizing agent, another for reducing agent. In these equations, now potassium permanganate is an oxidizing agent and ferrous sulfate is a reducing agent. So in the ionic form, I have written here, for oxidizing agent, if you compare the reactants and products of involving manganese, then you can identify. So MnO4 minus, this is the reactant side, ionic form, undergoes a change to Mn2 plus. This is a change undergone by the oxidizing agent. So I have just written here the ionic form. MnO4 minus is giving Mn2 plus. Now coming to the other side, reducing agent, ferrous sulfate, the ionized form Fe2 plus, I have shown, converted into ferric sulfate. So again, ferric sulfate 2Fe3 plus I have taken. So left side, half reaction for oxidizing agent, right side, reducing agent. So that is the step 1. Let me read again. Split the complete equation into 2 separate half reactions. One for the change undergone by the oxidizing agent, here permanganate, and the other for the change undergone by the reducing agent, here ferrous sulfate. I have shown here. That is the step 1. Okay, let me go for the step 2. Under the step 2, let me read now. Balance each half reaction not only with the numbers and kind of atoms, but also with respect to number of positive and negative charges as follows. This is the most important information. So step 2 gives very clearly, so we have to balance the equation each half, that is one for oxidizing agent, another for reducing agent. We have to balance not only with the numbers, but also the kind of atoms and then positive and negative charge also we have to balance. So the step 2 gives a number of sub-rules. So you can see carefully, and we should be very careful when we are balancing. Under the step 2, we have some number of sub-rules. 2a, we'll call it as 2a. What is that? Use simple multiples before each species so as to balance the number of all atoms except hydrogen and oxygen. This is under the step 2, the first rule. That means except hydrogen and oxygen, we have to balance all the atoms by simply on both sides we have to balance by adding a number. So in this case, I am taking the left side. This is oxidizing agent MnO4 minus 2 Mn2 plus. Right side Fe2 plus 2 Fe3 plus ferrous to ferric state. Okay. Now let me apply this 2a rule here. Use simple multiple before each species so as to balance the number of all atoms except hydrogen and oxygen. Except hydrogen and oxygen, we have to balance. Okay, let me see here. In this case, Mn, okay. So oxygen, left side, 4O, that is MnO4 minus. So I am not worrying about the 4 according to 2a. So except oxygen, so I am not worrying about. Right side, when you come that side, under the reducing agent, ferrous sulfate to ferric sulfate, right side there is 2, whereas left side there is no number. So what I have to do now? In this step here, so I am now introducing 2 left side. Now both side iron atoms are identical. Left side 2Fe, right side also 2Fe. So in this case, so I am keeping as such MnO4 minus arrow Mn2 plus because in the left side Mn equal. So the rule 2a says, so we need not worry about the oxygen. Except the hydrogen and oxygen, if any atom is not balanced, we have to balance. That is rule A, so that I have balanced. So in order to give a clear idea, so I can do other way also. Simply I can read the rules and finally I can balance. But for you to understand clearly, I am doing stepwise. Each and every step I am showing the corresponding equation, stepwise equation. So it will be very easy for you, student, to follow me. Okay, let me go for the next one. So step 2a, use simple multiples before each species so as to balance the number of all atoms except hydrogen and oxygen. The left side oxidizing agent, all atoms are equal, Mn equal, so I am not using any number. But as right side for reducing agent, left side Fe, only one atom, right side 2Fe, 2 atoms. So I am now putting 2 on left side. So this 2a is I have satisfied. So let me go for the next one, 2b. Under this step 2, what is 2b says? Add H2O to the side deficient in oxygen. Now only it is now giving information regarding oxygen. Regarding oxygen, what we have to do? The rule 2b says, whatever side it is deficient in oxygen, add H2O. So let me explain the suitable here. Example. So in the left side, I have shown you oxidizing agent MnO4 minus giving Mn2 plus of equations. So left side in MnO4 minus there are 4 oxygen, right side there is no oxygen. So according to 2b, so I am adding 4 H2O right side because the rule clearly shows 2b, add H2O to the side deficient oxygen. Left side MnO4 minus, right side there is no oxygen. So in order to satisfy that condition, in order to satisfy 2b, I am adding 4H2O. Very clear. What about the other part? That is the reducing part. So atoms already balanced 2Fe2 plus, 2Fe3 plus. So I am keeping as such. So I have satisfied 2b. Okay, let me go for the next one. 2c. Coming for 2c. Add H plus to the side deficient in hydrogen. That is, when in order to satisfy oxygen, when you add water, in this case we added 4H2O, so automatically in order to balance in water there is hydrogen, so to balance that hydrogen we have to add H plus to the other side, that is to the side deficient in hydrogen. So let me explain this specific example. So this is the previous equation we have added. Previous step, that is 2b we have seen already. We added, that is I added 4H2O. Right side, that is a reducing agent, we are not doing anything, we are keeping as such. Now, when we are adding this, when I am adding this 4H2O, so hydrogen is 4 into 2, 8 hydrogen is there. So in order to equate that, balance that, I am adding 8H plus on the left hand side. So this is to balance the hydrogen. So add H plus to the side deficient hydrogen. Since I have added 4H2 on the right hand side in 2b step, so I am adding 8H plus. So kindly remember. So now what is happening? M1 identical atoms are equal. Oxygen 4 oxygen again equal. And the 8 hydrogen left side, 8 hydrogen right side, everything are equal. Okay, let me go for the next step. That is step 2D. Let me go by the step 2D. What is 2D says? Add OH minus to the side deficient in hydrogen. This is for basic solution. So student, kindly remember here. Since the first equation I have shown you, this is the reaction. Redox reaction is taking place in acid medium. Since it is taking in acid medium, this OH add OH minus will not be suitable here. So this I will explain in another example after finishing that one. So in this specific example, this step is not applicable. Okay, let me go over the next step. Step 2E. Okay, we have ordered, we have balanced all the atoms on both sides. We have balanced. Now, the next step 2E says add electrons to the side deficient in electrons. Add electron to the side deficient electron, that is to balance the charges on the both sides. We have to add electron because electron is negative. So one electron means one negative. So to balance the positive charges, the charges, now we can add electron in a suitable place. Let me explain here. So let me repeat again. The step 2E says add electron to the side deficient in electron, that is to balance the charges on the both sides. Okay, let me take, this is the previous step I have taken 2D, and this is also I have taken from the rewritten here from the step 2D because we have to recollect from the memory otherwise. So what I have written here only from the previous step. So this is as per the 2D step. Okay, now all the atoms are balanced. So what I have to do now? Add electron to the third. But let me take first one, the oxidizing agent side. So in that case, left side 8H plus, whereas MnO4 minus 1 minus. That means the left side 1 minus plus 8 plus. That is plus 8. Then let me call 8, it is 8 plus. The idea here it is, the left side is 1 minus plus 8 plus, the total will be plus 7. Left side. Whereas if you compare here with the right side, Mn2 plus, only 2 plus is there. So left side plus 7, right side plus 2. So they are not equal. So in order to balance this, the rule 2E says add electrons. And which side I have to add? Now I am adding on the left hand side. So I have already pointed out here 8 plus, this is 1 minus, so 7 plus. From 7 plus, if I add 5 electron, 7 plus minus 5 negative, so automatically 2 plus on the left hand side, right side also 2 plus, now electrons are, now the charges are balanced. So, plus here plus 1, that is, sorry, this is minus 1, this is minus 1 in the permanganate, it is minus 1. And the plus 8H plus 8. Now here minus 5. So that means the left hand side minus 1 plus 8 minus 5 means the total, if you add all these things, that the left side will be plus 2. So right side is also plus 2. So the total charges are equal. That is to balance the charges on both sides. I have it. Now coming for the other part, second part, that is for reducing agent. Fe2 plus 2Fe2 plus arrow 2Fe3 plus. So 2 electrons I am adding on the right hand side because In this case, 2 into 2 plus 4 plus left side. Right side, 2 into 3 plus, it is 6 plus on the right hand side. The left side plus 4, right side plus 6. So automatically, to balance this, when I added 2 electron, so plus 6 minus 2 minus, automatically now plus 4 will be, that is automatically balanced. The left side plus 4, right side also plus 4. So automatically the charges are balanced in both sides. So this is the step. This is the most important step. So let me repeat again. Add electrons to the side, deficient electron, that is to balance the charges on the both sides. So the first case, I have added 5 electron left hand side. That is for oxidizing agent. In the second case, the reducing agent, I added 2 electron on the right hand side. So left hand side I added 5 electrons. Right hand side, that is of reducing agent, I added 2 electrons. What the next step? Let me go for the next one. Then, so far what I have done, starting from 2A to 2E, I have summarized here. The entire overall steps involved in step 2, I have summarized for your recollection. So kindly recollect. So this is the first step. We have written as step 1. This is 2, let us assume. 1 is the for oxidizing agent, half reaction, and the 2 for the reducing agent, half reaction. Left side, what I added first? 4H2O. I added, that is, this is a consolidate of step 2. 4H2O. Why I added 4H2O? To balance 4 oxygen. Since after I added 4H2O, automatically I introduced hydrogen is introduced. So in order to balance hydrogen, left side I added H+, 8H+. So all the atoms are identical. Now the next step, then we are balancing the including charges. So left side I am adding 5 electron in this. So automatically in this oxidizing agent, now total number of atoms as well as charges are completely balanced. So go for the other side, reducing side. So here first initial Fe2 plus, here only 2 Fe3 plus. So in order to balance the iron atom, I added 2 here. That's the first step. Now coming for the step 2, so we have to go for the balancing by adding electron. So 2 into plus 2, 4 plus left side, and 2 into plus 3 plus 6 right side. So minus 2 here, 2 electrons. Only after adding 2 electrons on both sides, the plus 4 will be there. So totally, it will be, the charges will be equal. This is the consolidated state. Okay, what the next step? Let me go for it. After this, now, step 3, we have to go for step 3. So step 2 is the most important part. That's why I have shown you the consolidated. Now, let me come for step 3. Multiply one or both half reactions by a suitable number. So that on adding the two equations, half equations, the electrons are balanced. This is the most important. So what is that? The electron should be balanced, should be equal in both sides. Let me repeat again. Multiply one or both half reaction. In this case, permanganate 2Mn2 plus, MnO4 minus 2 Mn2 plus, oxidizing agent. The other one, Fe2 plus 2 Fe3 plus. Two half reactions. So, in these reactions, so multiply one or both half reaction by a suitable number, so that on adding these two equations, we are going to add these two. When you are adding, the electron present in this equation should be balanced or balanced. Okay, let me explain this factor here. That is step 3. So this is the step I have brought from the step 2. This is again from the step 2. Okay, now in this step 3 says, now left side there are 5 electrons, in this case in the oxidizing agent, and the right side there are 2 electrons in the reducing agent, ferrous sulfate to ferric sulfate. According to step 3, I have to multiply a suitable number so that both cases total number of electrons should be same. That is, electrons should be balanced. Okay, what I have to do now? So minimum number I have to use. So I am now multiplying by 2. So when I multiply by 2, 2 into 5, that will be 10 electrons for the oxidizing agent. The same way, Now the second one I have to multiply by 5, so that 5 into 2 also 10 electron. So this by multiplying 2 the oxidizing agent, by multiplying 5 the reducing agent, now the total number of electron in both cases will be identical, that is 10 electron in both cases. Just see here in this equation I have shown you. So now I added 10, that means 2 into 5, 10 electron I added. The same the second case, 5 into 2, the total number of electron is 10. So both cases 10 electron, this is the step 3 state. Multiply one or both half reactions by a suitable number, so that on adding the two equations, the electrons are balanced. So in this case, I have shown you, first case I have multiplied by 2, I got 2 into 5, 10 electron. Second case I multiplied by 5, 5 into 2, 10 electron. In both cases, 10 electrons. So now we have to add this. Let me go for the step 4. I have shown here, add the two balanced half reaction. So what I have shown you in the step 3, I am by adding this, on the left hand side reactants I have added one side, on the right hand side product I have added the other side. So equation 2M1O4 minus plus 16 H plus 10 electrons, then 10 Fe2 plus, this is the overall total of left side, that is oxidizing as well as the reducing agent of left side. The other side 2M12 plus 8 H2O plus 10 Fe3 plus and 10 electron, this is on the right hand side. So automatically 10 electron cancel. So from the step 4, now we will get this final equation, this one. This is the ionic equation, we are getting the final. So add the two balance of reaction. After adding 10 electron left side and 10 electron right side will be cancelled. The final equations we are having this. This is the final equation. 2M1O4 minus plus 16H plus plus 10 Fe2 plus arrow 2M12 plus 8H2O plus 10 Fe3 plus. So if you count now, all the atoms identical, all the charges are identical, everything will be identical. Let me verify, just see here. Left side 2Mn, that is manganese 2 atoms. So here also 2 atoms are there. So both sides, manganese atom, both left side as well as right side balanced. Okay. Coming for next one is oxygen. 2 into 4, 8. So 8 oxygen here is also in water, 8 oxygen. So oxygen is also balanced. Coming for the hydrogen, 16 hydrogen, left side. The right side, 8 in water, 8 into 2, H2. So it is again 16. So hydrogen is also balanced. And finally coming for the iron atom. Left side 10 Fe, right side is also 10 Fe. So all the atoms are balanced. Coming for the charges. So now coming for the charges in the sense, actually, if you count that one, total number of charges on both sides, again automatically it will be balanced. Okay, let me go for the next step. What I have to do now? So we have now, after adding, electrons are cancelled. So we are getting a final equations. So now this is the final equation we are getting for the previous step. 2M1O4 minus plus 16H plus 10 Fe2 plus 2M12 plus 10 Fe3 plus 8H2. This is the final equations, ionic equations after adding these two. Okay, what the step 5 says? According to step 5, frame the skeleton of the equation from step 4. This is the step I have taken from the 4 equation from the step 4. So frame the skeleton from this ionic equation. I have to frame the skeleton. What way? By representing atoms, molecules or compounds and balance further if necessary. Even after introducing this, after representing atom, molecule or compounds, sometimes automatically it will be balanced. Sometimes if it is not balanced, then balance further if necessary. Let me explain here. So let me take this same ionic equation in there, that is the next step, step 6. Now actually here I am saying the step 5. Now I am showing this is the equation previously I shown. So using this ionic equation, now I am going to convert, I have to represent in terms of atom, molecule or compounds. So MnO4 minus, so from the original equation, this is nothing but 2MnO4. So instead of 2MnO4 minus, I am introducing 2K-MnO4 because MnO4 minus compound ions, nothing but from the, it is come from potassium permanganate. So the 2 number I am putting there. Now again coming for the H plus, 16H plus, the correspondingly if you see the original equation, H2SO4, so 8 sulfuric acid I am putting, 8 into 2 automatically 16. So in order to represent sulfuric acid, I am using 8 H2SO4. Then coming for the 10Fe2 plus, I am converting into again a compound, the form of 10FeSO4, ferrous sulfate. So these 3 substances we saw originally in the equation, stoichiometry, unbalanced equation. Now we are getting the number 2 for KMnO4, 8 for H2SO4, 10 for FeSO4, ferrous sulfate. This is for reactant side. Coming for the product side, 2Mn2 plus, Mn2 plus nothing but manganese sulfate. So automatically I am introducing 2MnSO4. 2MnSO4 I am introducing for, because I am representing 2MnF2 plus, for that I am representing 2MnSO4 with manganese sulfate. The same way, now just to take now here 10Fe3 plus. Fe3 plus originally is ferric sulfate, so the ferric sulfate compound I have to represent, but the number is 10. So in order to keep that one, I will put 5 times here, like automatically 5 into 2 Fe2SO4 thrice. So 5 into 2 means 10. So it is satisfying this condition. So I am putting 5 Fe2SO4 thrice. So the reason I have already explained, because here Fe2 means 2 iron atoms. So 5 into 2 10. So that is satisfying the 10. So I have represent then Fe2SO4 thrice. And finally, 8 water as such I am representing. Now, only one more we have not represented here, because in the original equation, potassium sulfate was written on the right hand side, it was not indicated, because it is not indicated here because it is not in the, but it is not undergoing oxidation or it is not undergoing reduction. So automatically, so now we have to include that one also in the final step. So let me show you that. So this is the final balanced form conversion. I am using the word now conversion means. I have already written the 2 KMnO4, 8 H2SO4, 10 FeSO4 for left side. Right side, this is the potassium sulfate I have brought from the original equation, which is not involved in the ionic. That's most important. Then 2 MnSO4 I have already explained you. 5 Fe2SO4 thrice I have already taken used. And 8 H2O. Now this is the conversion. Now, the previous step shows if it is necessary, balance, it is given. The last step. So let us see, verify here. If it is balanced, okay. Otherwise, we have to go for final balancing. Let us verify from this, whether it is balanced or not. So if you compare these two equations, 2 KMnO4, 2 KMnO4, 8 SO4, 8 H2SO4, 10 FeSO4, 10 FeSO4, and right side K2SO4, everything identical. K2SO4 identical, 2 MnSO4 identical, 5 Fe2SO4 thrice again identical, and both cases conversion as well as balance identical. Some cases if it is not balanced, we have to balance. Okay, let me verify now finally whether the particular equation is completely balanced or not. Let us verify now finally what we have to do. Now as usual, 2K, 2K, it is there. Okay, balanced. 2K, 2K is balanced. Then coming for 2Mn, 2Mn, it is again right side. Left side 2Mn, right side 2Mn, it is again, okay, balanced. Now, coming for hydrogen, 8 into 2, 16, again 8 into 16, in water it is 16, so hydrogen is satisfied. Now, coming for, well, let me take only sulfur, so 8 sulfur in this case, then 10 sulfur, 8 plus here 10 sulfur, here 8 sulfur, here again, so left side 10 plus 8 sulfur, total number of sulfur atoms. Coming for the product side, here 1, here 2, here 3, that is 15. Total is 15 plus 2 plus 1, total again 18. So sulfur, left side 18, right side is also. So sulfur is also identical. So now only remaining is we have to go for oxygen. So let me count oxygen. So here 2 into 4, 8 oxygen here, left side in this case. Here 4 oxygen in sulfuric acid, 8 into 4, 32. Total is 32. Then here in ferrous sulfate 4 oxygen, 10 into 4, 40. So total oxygen left side is 8 plus 32 plus 40. Total is 80. Left side 80. Now we have to count right side also whether the total number of oxygen atoms are identical. Now let me start now. This is 4, potassium sulfate 4, and manganese sulfate 2 into 4, 8. Then here in sulfate, ferric sulfate 4 SO4, 4 oxygen, 3 into 4, 12, 5 into 12, 60. Then here it is, in water there is 8. So totally, let me write, first one is 4, right side, 4 plus 8 plus 60 plus 8. You count the total, 68, 76, 80. So, left side as well as right side, the total number of oxygen atoms also 80. So, all the atoms are well balanced. This is the importance of ion electron method. So, if you are not following systematically the steps involved in ion electron method, sometimes it will take you problem, minimum more than 1 hour it will take. But when this question is asked in IIT and other question paper, you have to answer the question within 1 minute. What way? They will simply say the corresponding species they will take, 4 species they will take, what way? This permanganate 2. So for example, they will take ferrous sulfate 3, again 10, and again the right side, manganese sulfate 2, so ferrous sulfate 3. Like this, they will take species. In the table column, they will indicate MnO4 minus and Fe2 plus, right side again 2Mn2 plus and Fe3 plus, they will indicate, and below that they will give option A, B, C, D, etc. So option A, 2, then 10, 2 and 5, they will give the number. Like this, they will change the options, so that is different options. Then they will ask the question, identify the correct coefficient to balance the equations. So what you have to do now, you have to balance the equations and find out the corresponding species, what number is correct number, that you have to, in which choice it is there, then you have to take. So this is the IIT questions. So if you go systematically following the rules, you can balance. Okay, this is regarding for ion electron method in acid medium. Let me give one more example to give an idea for basic medium, because in the equation I have discussed you already. In the case of basic medium, we have to use OH minus, because the one important information just I want to give, because when you are discussing the equivalent mass, potassium permanganate in acid medium, it is molecular weight by 5, whereas in the case of basic medium, molecular weight by 3. This is the most interesting information in stoichiometry. So here, let me show you the example 2, but here I am not going to explain you in stepwise. I will give the consolidated overall steps, because I know I have given you already. So let me explain this one. So this is all the steps I will show in a single, because assuming that you understand that. Okay, now we'll kindly follow that. Ion electron method. So in this case, so what we are using here, it is MnO4 minus, the left hand side equations, MnO2, the corresponding ionic form, that is the other side, I minus 2, I2. So this is the corresponding 2-half reaction that we are going to use. So what is the rule they are? They're based on the same rule. Let me go systematically, because assuming that you know everything. Okay, just see. This is for the left hand side. First let me go for left hand side, then I will come for right hand side. So MnO4 minus, right side MnO2. So both side manganese ion atom is there, but oxygen is not identical. So left side 2, right side 4. So in order to balance oxygen atom, I am adding 2H2O. Okay. So now total number. So in order to satisfy this hydrogen, left side I am adding 4H plus. Okay. So after adding 4H plus, what we have to do in the next step? So the atoms are balanced. Now only thing is we have to go for the charging. That is, now in this case, the idea here is, since we added 4H plus, the only step you have to, kindly remember now students, the case of alkali media, basic media, now I am using now. So both cases I am multiplying by 4OH minus on both sides. The left side 4OH minus, right side also 4OH minus, because then only the H plus will be removed. Because I should not introduce H plus, means an acid. I cannot introduce H plus. So in order to neutralize that, I am multiplying both sides 4OH minus. This is the important step in alkali media, kindly remember. So both cases I am multiplying 4OH. So 4H plus 4OH minus will be converted to 4H2O, water, and right hand side 4OH minus. So automatically the equation will be MnO4 minus plus 4H2O, right side MnO2 plus 2H2O plus 4OH minus. Now, so everything is balanced except the charge. So now I have to balance the charges. Like just see the left side 1 minus, the right side 4 minus. Left side 1 minus, MnO4 minus 1 minus, right side it is 4 minus. So charges are not equal. In order to balance the charges, what I have to do now? So left side I am adding 3 minus. So automatically 3 minus plus 1 minus, totally 4 minus left side. Automatically 4 minus on right hand side, both will be identical. So this is the balanced form of this left side. MnO4 minus plus 2H2O plus 3 electrons, arrow MnO2 plus 4OH minus. So this is the left side part. Okay, let me go for the other side. So let me come for this one. I minus converting into I2. This is the second part. Right. So iodine atom, left side 1 atom, right side 2 atom. So I am adding 2. So both cases 2. What is the only thing is charge is not equal. Left side 2 minus right side 0. So automatically to balance that, right side I am adding 2 electrons. So now including both cases, both half, left side and right side, for oxidizing as well as reducing agent, I have now balanced such a way that both half reactions. So total charge including atoms, charges, everything equal. The only thing is you have to kindly follow left side 3 electron, right side 2 electrons. So what is the final step you have seen? So we have to add these two equations. Before adding, we have to multiply by a number so that on adding the both side total number of electrons will be same. So what is the minimum number I can use? So first I will, the first case I will multiply by 3, second that is second case I will multiply by 2. Let me show you now, so total number will be identical. Just see, I am recollecting that. That is, I am just brought forward here these two, the previous step. So 3 electrons on the left hand side, 2 electrons on the right hand side. What I am doing now? The first case I am multiplying by 2 to convert 3 electrons. So 2 into 3, total will be 6 electrons. The same way, the other part, second part, 2 electron is there. So I am multiplying by 3. So total again 6 electron. So left side 6 electron, right side 6 electron. So total. So we are going to add 2. When we are adding, automatically the 6 will be cancelled. So this is the final form of that equations. So 2 MnO4 minus plus 4H2O, 6 electron on the left hand side. The right hand side 2 MnO2 plus 8OH minus. The second part, that is the other part, 6I minus arrow 3I2 plus 6 electrons. Now, so now we have to add these two equations. When you add these two, automatically 6 electrons will be cancelled. Now we can see that one. So in this, I have again from the previous step, I have brought this equation here. These two equations I have brought from the previous step for our understanding. Now, just to avoid confusion, I am using the term now. 1H means I am showing the stepwise. 1H the previous step, there's a 2E, that is previous case we have seen that one. So add equation 1H and 2E. That is nothing but, just see here, this is the 1H and this is the 2E, just to represent that I am saying. So in this case, now add these two equations, 1H and 2E. So left side, 2 MnO4 minus plus 4H2O, 6 electrons, plus 6I minus. So that is, I am taking this, and this on the left hand side. And coming from the other side, 2M1O2 I have written here, 8OH I have written here, then 3I2 I have written here, from the 6 electron I have written here. So when you compare both sides, electron, 6 electron is getting cancelled. Left side 6 electrons, right side also 6 electron cancelled. So now, after that, we have to convert this entire ionic form to the normal, the atoms or molecules or compound form we have to convert. If it is necessary, we have to balance. So just see here, from 2M1O4, I am introducing to KMNO4, potassium permanganate. 4H2O, as such, I am using 4H2O, I am not changing anything. So 6I minus, I am using 6Ki. The corresponding 2M1O2, I am using 2M1O2 as such. 8OH minus, I am using potassium hydroxide, the base. So 3I2, I am using 3I2. This is the most important information. That is, now we have to verify now whether the equation is balanced or not. Because why I am giving the second example, it is involving potassium hydroxide, a base. Now I am giving another example. Now let us see here. So 2K, that is plus 2K plus 6K, 8K cancel. So total number of the potassium atom on both sides identical. Mn, 2Mn, left side 2Mn, right side 2Mn cancel. That means identical. Then hydrogen, 4 into 2, 8. Again 8H here is again identical. So 6I, again 3 into 2, 6I, it is identical. Now we have to count only the oxygen atom. 2 into 4, 8 oxygen here, 4 oxygen here, plus 12. In this case, 2 into 2, 4 oxygen. In this case, 8 oxygen. So 8 plus 4, identical. So total number of oxygen also identical. So in both cases, all the atoms are identical. So by using ion electron method, by following systematically 5 steps, we can balance any ionic equation without any problem. This is the most important information. So in this case, I have given 2 redox reaction. One for, in acid medium, I have given example, potassium permanganate, sulfuric acid and ferrous sulfate, I have taken. In another case, I have taken this potassium permanganate water plus Ki, it is involving potassium hydroxide. So this is the most important information regarding ion electron method. So in the stoichiometry, the first part is, the most important is we have to balance. So as I have already discussed, balancing of any chemical equation can be done by 3 ways. One is heat and trial method, 2 oxidation number method, and just third method is ion electron method. Just now I have discussed. So now we have to go for the next one is the corresponding conversion, stoichiometric conversion. Now, stoichiometric conversion, this is the another most important we are getting from the stoichiometry. So coming for these stoichiometric conversions, what we can do? We can convert mole to mole, we can convert. We can convert mole to mass, we can convert. We can convert mole to volume, we can convert. This is the most, again vice versa. So mole to, that is mass to mole, volume to mole. So anything we can convert. Even particle we can convert. So I have already discussed when I was discussing the atom molecular mole concept, I have discussed very clearly, mole can be expressed by molar mass, mole can be expressed by molar particle Avogadro number, mole can be expressed in the form of molar volume. So, and vice versa. If you again molar mass can be converted into molar volume can be converted into particle provided if it is a gas, and particle can be converted into molar mass. So by 6 combination, we can convert one form to another form with the help of stoichiometry. We'll call it a stoichiometric conversion. So let me take one or two, some 3 or 4 problems to explain the fact. Okay, let me take example number 1. So before entering into that, let me take a known example to give a clear idea what are the way you have to think of. Then if I go for the problem, you can very easily you can follow that. Let me take now. Suppose I will take now helium atom. Let me take helium atom. 1 mole of helium, let me express now, 1 mole of helium, what will be the molar mass? Helium is an atomic element, the corresponding atomic mass is 4 gram. So, the 1 mole of helium weigh 4 gram. That's the first information we will get. Then, it's a gas, helium, monatomic gas. So, automatically, molar volume is nothing but, according to our hypothesis, 22.4 liters. 22.4 liters, 1 mole of helium gas will occupy a volume of 22.4 liters. Coming for the particle, it is a particle means atom, atomic element. So 1 mole of helium will contain Avogadro number 6.023 into 10 to the power of 23 atoms. This is the most important atom. Particle is the atom. So these are the, so when you know what is the element, immediately we have 3 information. If you know the name of the element, name of the molecule, name of the compound, immediately we have 3 different information. One is molar mass, you know. Molar mass, here it is an atomic mass, if it is an atomic element. But molecular mass, if it is a molecular element or compound. Coming for the gas, if it is a molar volume. And if it is a particle, we can easily, so we can very easily identify immediately if you know that. Well, this is the part, an atomic element helium. Let me take a molecular element by taking hydrogen, like we discussed. Now, I hope everybody know that. What is the molar mass? We know atomic mass 1, so it is 2 grams for hydrogen. Then, molar volume is a gas, as usual, 22.4 liters again. Or, we can already say 2.24 into the power of minus 2 meter cube. We have discussed already. Coming for the particle, as usual, this is a molecular element, so 6.023 into 10 to the power of 23 molecules. Kindly follow. It is molecules. So in the case of helium, I informed you it is an atom. Particle is atom. But in the case of hydrogen, it is called, they are calling it as molecular. Again, molecular elements. So one more example I will give before entering into the problem. That is, let me take now carbon dioxide. Or if you take specific example, methane, let me take. Methane, let me take now. Methane. So coming for the methane, 1 mole of methane is a gas. So molar mass, carbon 12, hydrogen 4, 12 plus 4, 16 gram. So molar mass, 1 mole of methane gas weighs 16 gram. Since the gas, 1 mole of methane gas will occupy a volume as usual, 22.4 liters. 4 liters. And it's a compound. Kindly follow me. Methane is a compound. We got more than 2 atoms, carbon and hydrogen. Atom. So we'll call it a molar. It's a compound. So molecular compound. So particle is nothing but again molecule. So 6.023. That is 6.023 into 10 to the power of 23 molecules. This is for methane. 6.023 to the power of 23 molecules. So 1 mole of methane will contain. So these are the informations we are getting immediately if you go for the mole. So with these informations, now we are going to solve problems with the help of stoichiometry, that is balance equation. So let me go for the next. Now, stoichiometry conversion. So how stoichiometrically we can convert mole to mole, mole to mass, mole to volume, and vice versa. Let me explain. So in order to explain this factor, stoichiometric conversion, let me take a standard equation, stoichiometric equation, that is combustion of methane. So because it's a very, very simple fundamental equation, normally you might have been studied in 8th and 9th standard. Let me take it now. So methane, 1 mole of, listen me, I am giving in terms of mole. 1 mole of methane reacts with 2 moles of O2 to produce 1 mole of carbon dioxide and 2 moles of water. So if you want, this is gas, this is gas, this is gas, this is liquid or a vapor form if it is. Okay. Now just see here. So this is the important information. So from the stoichiometry, now what I can see in terms of mole-mole conversion, I can speak now easily. So 1 mole of methane is required to produce 1 mole of carbon dioxide. So in a stoichiometrically, if I burn in oxygen, excess oxygen, 1 mole of methane will produce 1 mole of carbon dioxide. In other way, if I use 2 moles of oxygen, automatically it will produce 1 mole of carbon dioxide. So this is the mole-mole conversions. The same way, the same equation. So I can speak in terms of even grams. Let me see. So what is the molecular mass of methane? As I have already pointed out, specifically 12 plus 14. So 16 grams. We know oxygen molecular weight. 16 plus 16, 32, 2 into 32 again. So actually 16 plus 16, 32, it is 2 into 32. So automatically this will be 64 total plus 16. Now coming for the other side. So total here it is carbon 12, oxygen 32 plus 12, 44 plus 2 into 18, molecular weight of water is 18, so 36. So in terms of gram, now just see right hand side again 80 and left hand side again 80. So it is obeying the law of conservation of mass, the fundamental gas laws, that is laws of chemical combination. So in terms of mass we can now speak. What way? Suppose 16 grams will be sufficient to produce 44 grams of carbon dioxide. Or if I want to compare 1 mole to gram, that is 1 mole of methane will produce 44 grams of carbon dioxide. Or 2 moles of oxygen will be required to produce the 44 grams of carbon dioxide. Now I am speaking in terms of mole to gram by using the same stoichiometry. So depending upon the requirement that is question asked, we can convert anything. Or in terms of volume also I can speak. What way? Suppose I want to speak about the carbon dioxide. So I can say 1 mole of methane will produce 22.4 liters of carbon dioxide. In terms of volume I am speaking now. 1 mole of methane will produce 22.4 liters. That is conversion here it is mole to liter volume. The same way 2 moles of oxygen will produce one that is 22.4 liters. Again mole to volume. So if you have a stoichiometric balance equations, we can convert any form from mole to volume, mole to particle, mole to gram, anything, vice versa we can. Now let me go for the problem, then you can understand that. Let me take this problem. Kindly read this problem. You can take how many moles of oxygen are required to produce 5 moles of carbon dioxide? Very simple. The question is, kindly read the question. What they are asking? The question is how many moles of oxygen required. So this is they are asking how many they are asking. Okay. So what is there to produce? 5 moles of carbon dioxide. 5 moles. So our aim is I want to produce 5 moles. To produce 5 moles, how many moles of oxygen required? So from the stoichiometry, what information we can get? Very simple. 2 moles oxygen will produce 1 mole. 2 moles of oxygen will produce 1 mole of carbon dioxide. So to produce 5 moles, how many moles of oxygen required? This is the information we know. So it is a mole-mole conversions. Let me show you very clearly this problem. I will solve this problem. Just see here. This is the stoichiometry. So write the stoichiometry. Okay. Now I am writing in terms of the sentence. To produce 1 mole of carbon dioxide required oxygen equal to 2 moles. Just see from the stoichiometry. To produce 1 mole of carbon dioxide, required oxygen is 2 moles. That I am writing in the form of sentence. So whatever required I am writing on the right hand side. Required oxygen is 2 moles. To produce 5 moles of carbon dioxide, required oxygen will be how much? It is automatically 2 divided by 1 into 5 will give the answer, that is 10 moles. So this is the way. Or even without writing the sentences, we can simply do this way. Simple calculation. So what is now? So it is given oxygen is 2 moles. The correspondingly, the required again, this is produced from 1, that is 1 mole of carbon dioxide is produced. So what you need is 5. So opposite is 1 is mole of carbon dioxide. So this is the 1 mole of carbon dioxide. This is 2 moles of oxygen. So it is produced to 2 mole producing 1 mole of carbon dioxide. So to produce 5 means simply multiply by 5 into 2, you will get the 10. That is this here. So instead of writing the sentences even directly, you can calculate this. So this is the mole-mole conversion. So I will go for the next problem. In this case, another problem is here mole mass conversion I will show using a stoichiometry. As usual, again for simplicity, I have taken same original equations. 1 mole of methane plus 2 moles of oxygen to produce 1 mole of carbon dioxide plus 2 moles of water. This is the same balanced the equation, stoichiometric equation. So now, so what you need, how many grams of oxygen required to produce 5 moles? So that means conversion to mole to mass. So let me explain now. So from this, here I have written already the original equations. So below I have shown you the corresponding in grams. So what is that here? 16 gram carbon methane, 2 into 32 again oxygen, 44 gram carbon dioxide and 2 into 18 gram water. This I just now have already explained to you. So how to solve this problem? Very, very simple. Just see here. In this case, so mole mass conversions. Kindly guess, again is the same thing. This I have brought from the previous one. So to produce 1 mole of carbon dioxide, required oxygen is 16 grams. Because the asked question is how many grams required, oxygen required they have asked. So to produce 1 mole of carbon dioxide, required oxygen equal to 64 grams. That is 2 into 32, that is 64. To produce 5 moles, so simple, 64 by 1 into 5 will give the correspondingly 320 grams of oxygen required. So if you take and allow to burn with the methane, that is 320 grams. If you take oxygen with excess of methane, automatically you will get the correspondingly, you will get the 5 moles of carbon dioxide will be produced. This is the important information, mole mass conversions. Okay, next, let me go for the next one. Stoichiometric conversion. Regarding mole volume conversion, I can give you another problem. How many liters of oxygen? So the volume, question is now volume. How many liters of oxygen are required to produce 5 moles of carbon dioxide again? So our aim is we want to produce 5 mole, and how many liters of oxygen we have to utilize, we have to use. That is the question. Again, as usual, stoichiometry, and we will go for the problem. So in this case, I am using actually usually the corresponding stoichiometric equation, balanced one. So oxygen, I am now expressing in terms of liters, volume. We know 1 mole means corresponding to 22.4 liters. Here 2 mole, 2 into 20.4 liters. It's required to produce correspondingly 1 mole of carbon dioxide. To produce 1 mole of carbon dioxide, required oxygen 2 into 22.4 liters. You can see here 2 into 20.4 liters. So how we are getting this information? We are getting from the stoichiometry, balanced equation. Okay, so our aim is to produce 5 moles, how many the liters of oxygen required? So that we can balance simply. So 2 into 20.4 divided by 1 multiplied by 5. If you calculate this, you will get this 22, that is 224 liters of oxygen will be required. So if you solve this problem, automatically we are getting this in terms of volume. So here we are converting mole to volume. So whatever we are getting, the correspondingly we can convert this. Okay, let me go for the next one. So volume mass conversions. So that is one more. So from volume, mass can be converted. This is one information I am just. So again, read the problem here. The problem is how many liters of oxygen are required to produce 220 grams of carbon dioxide. So far I have used in all the problems moles. In terms of mole I used. Now in this case for the first time I am changing to gram. In mass I have used. So volume to mass conversion I am giving an explanation. Just see here, I should just see the stoichiometry, and we are giving in the terms of 1 mole of methane gas plus 2 moles of gas, O2 gas, 1 mole of carbon dioxide gas, 2 moles of liquid, that is 2 moles of H2O liquid. So this is the stoichiometry. Now how to do the problem? Go for that. That is, In the stoichiometric conversions, just see as usual, I am now representing the same equation. So I need, that is, how many liters of oxygen required to produce correspondingly, that is, the question is 44 grams of carbon dioxide. So here, let me use this same stoichiometric equation I am using here. To produce 44 grams of carbon dioxide, 44 nothing but molecular mass of carbon dioxide. Carbon 12 plus the 16 plus 16 for oxygen, so totally 44. So to produce one more, that is equal to 44 grams or it is equal to 22.4 liter, anything we can get from the mole informations. So to produce 44 grams of carbon dioxide, required oxygen equal to 2 into 22.4 liters. That we are getting again from the mole. As from the case of oxygen, mole, 2 moles. In terms of volume, 2 into 20.4 liters. In terms of mass, 2 into 32 grams, that is. So anything we can express. In this case, so we are expressing to produce 44 grams of carbon dioxide, required oxygen is in terms of liter, 2 into 20.4 liters. So to produce 220 grams of carbon dioxide, required oxygen equal to 2 into 20.4 divided by 44 into 220 will give the correspondingly, that is 220. That is this 44 and 220 if you divide by this, it will be 5 times will come 5 into 210. So 10 into 20.4 will give the 224 liters. So I have given some 4 problems I have given to explain you how stoichiometrically we can convert mole to volume, mole to mass, and vice versa. So I hope by using this, by watching these lectures, I hope you can take your books, any problem if it is given, very easily you can solve it. What is the method? Let me give a guideline, guide you. What you have to do first? First, take the equations and just find out and split the equation. Just what method you are going to follow. It's a hit and trial method, or oxidation number method, or an ion electron method. So if it is a complex one involving ions, electron, etc., so better we have to go for ion electron method. Then take the ion electron method, split equation as following the 5 steps I have discussed, balance the equation. After the equation is ready, then go for the stoichiometric calculations depending upon them. Then look at each nature of the reactant product, everything you look at that. Then you have a clear idea. So whatever question is asked, then correspondingly substitute properly, you will get the answer. And I hope you have enjoyed this stoichiometric part 2, and I hope hereafter when you go for any balancing equations, then you can do it systematically. Thank you.